solve, check your result. We have the rational equation in which we want to multiply both sides by the LCD. Notice that the product of x minus 2 times x plus 2 is x squared minus 4. And therefore, the LCD is x minus 2 times x plus 2. So we multiply both sides by x minus 2 times x plus 2. Let's put this in brackets to show that each of those terms needs to get multiplied by the LCD. On the right-hand side, we multiply by x minus 2 times x plus 2. On the left-hand side, when we distribute, the entire x minus 2 times x plus 2 cancels with the x squared minus 4, leaving the result of 1. Then we have minus. When we distribute the x minus 2 times x plus 2 here, the x minus 2's will cancel, leaving us with the subtraction of x plus 2. On the right-hand side, our x plus 2's will cancel, leaving us with 1 times x minus 2, which of course is just then x minus 2. Distributing the minus sign here, we have 1 minus x minus 2 equals x minus 2. Let us add x and add 2 to both sides. On the left-hand side, the result is 1, and on the right-hand side, the result is 2x. Therefore, we can say that x is equal to 1/2. Let's do our check. So what we want to do then is substitute 1/2 in for x and check to see that the left side equals the right side. So we will have 1 over 1/2 squared minus 4 minus 1 over 1/2 minus 2. We want to know, does that equal 1 over 1/2 plus 2? 1/2 squared is 1/4. And so we would have 1 over 1/4 minus 16/4, changing the 4 into 16 over 4, minus 1 over 1/2 minus 4/2, changing the 2 to 4 over 2. We're still interested in, does that equal 1 over 1/2 plus 4 over 2, changing the 2 into 4 over 2. Now in this denominator, 1/4 minus 16/4 is 1 over negative 15/4 minus 1 over negative 3/2. Does that equal 1 over 5/2? When we have 1 divided by negative 15/4, we take the reciprocal of 15/4 and multiply it by 1, so negative 4/15. We have a double minus here, so it's plus. And then 1 divided by 3/2, we take the reciprocal of 3/2, which is 2/3, and multiply it by 1. On the right-hand side, 1 divided by 5/2, we take the reciprocal of 5/2, which is 2/5, and multiply it by 1. So we're still interested in knowing whether these are equal. We need to change the 2/3 so that it has a denominator of 15. So this means we multiply top and bottom by 5. So what we would have is negative 4 plus 10. Well, negative 4 plus 10 is 6. So that would be 6 over 15. But we can reduce 6 over 15. It reduces to 2/5, which of course is equal to the 2/5 we were looking for, and therefore it does check.